So the propagation of uncertainty in the previous video was all about giving your final sort of precision value. Now you're going to give your final sort of accuracy value, and that sort of finishes off the calculations for the experiment in your report that you normally would do. So absolute error is just minusing your value from what the published value is. We normally do a percentage error. That gives us a more relative, a clearer idea on how well the experiment was done. And so we basically take a percentage of that. So the formula is here. So we just get the published value or accepted value and minus ours, and we just take the absolutes here, so you could do either way. So we just want a positive value. And so this is the accuracy here. And I've put it similar to percentage uncertainty, but that is the previous value about precision that you want to talk about. And so we have an example here. So you found a density of this, and the true value is this. So you minus them from each other, you get this value, and then divide it and you get that value, and you get 0.5935. Do it to 1 sig fig, and then report that your percentage error is 0.6%, which is rather good. Often a 20% error is bare minimum for most science experiments. Depends how the chemistry experiments, depends how they're set up. Sometimes they can be significantly worse, such as 50% for heat loss if it's not a proper calorimeter and you're doing a thermochemistry experiment.